So the next modeling technique we're going to talk about is interactions. And so we're kind of going to really briefly talk about it here and now, but then we're going to kind of revisit it once we introduce qualitative variables or kind of binary variables, or kind of review them in the next chapter or the next module. But let's kind of introduce them now so kind of understand kind of what they're doing, but we'll come back to it next module. So interactions. So as the name suggests, this is when we interact two of the independent variables together. So it's a modeling technique that allows the marginal effect of one variable to be dependent on the level of another. That allows the partial effect of one variable to depend on the magnitude of a different variable, or the level of a different variable. Another variable. Let's just write it out. So what I mean by that is we could have a regression. Let's do a general one, and then again we'll come back and kind of look at an example. Y equals beta 0 plus beta 1 times x1 plus beta 2 times x2, and then here's this interaction. Let's do it in a different color so maybe it shows up a bit better. So beta 3 where x1 times x2. So this is that interaction because they're multiplied. This is like a new variable that's these two independent variables multiplied by each other. And then let's go black to blue. Maybe we have another one, beta 4 x3 plus u. And so now if we think about what the effect, so if we're interested in the partial effect of x2 now, we're going to take the derivative of this right-hand side with respect to x2. Well, then we have this beta 2 plus, take the derivative with respect to x2, this becomes a 1, beta 3 times x1. So this is this extra term because of this interaction. So now the partial effect of x2 depends on the level of x1. So let's kind of write down an example with kind of actual variables, and we can talk about what this would mean intuitively. But here, now the partial effect of one variable relies on the level of another. You know, we could do the exact same thing for x1 here, where the partial effect is beta 1 plus beta 3 times x2, right? It's the same thing. They're interacted with each other. So the partial effect of x1 depends on the level of x2 now. So let's look at an example of interactions with kind of actual variable names, so maybe we can get up some intuition as opposed to y's and x's, because sometimes that's hard to kind of understand what's going on. Let's go back to my favorites. We're thinking about wages again. Our example seems to be about wages, kind of returns to education, but let's say we're interested in what influences wages, and we have years of education as one of our x variables. And then what we're doing is this beta 2 is going to be years of education, this interaction with parents' education. So this is parents' education times education. So this is years of education for the person, and this is their parents' education here. So that's that interaction. And we also might think experience might affect your wages, and let's say tenure as well. So number of years, tenure for number of years you are working at your current company or your current job. Okay, so let's say this is the regression. So let's think about, so now the partial effect of education, the change in log wage. So we're not going to think about the change in wages, but let's just look at the change in the log of wage. Is going to be equal to beta 1 plus beta 2 times parental education. So what this means is if beta 2 is greater than 0, that means someone whose parents are more highly educated get larger returns to education. So orange is a color we haven't used yet, so let's do it in orange. So if beta 2 is greater than 0, that means returns to education are higher or larger for individuals or people with more educated parents. So if we think that might be true, we want to test if that's true, we might want to run this regression with this interaction here. Now, notice that we can't get like an actual number for what the effect of education is, right? Because it depends on the level of parental education. So if we ever want to get kind of an actual number for what the effect of another year of education and on your wages, we kind of want to evaluate this partial effect at a particular, maybe hopefully interesting level of parental education. So when we want to look, is that's what that's supposed to say, on the effect of education on wages, we want to evaluate the partial effect at, I'm going to put in brackets, interesting, or sorry, in quotes, interesting levels of parental education. So, we're not going to get a number because the actual returns to education depends on the parent's education. But maybe we want to evaluate this parental education. So instead of just leaving that like this, maybe we're interested in if they both parents have a high school degree. So they might have 24 years of combined education. Well, maybe we want to evaluate this at 24. Maybe we're interested in different levels or just elementary school level. Then we want to evaluate that at, let's say, elementary 6. Maybe we want to evaluate that at 12. So parents combined have a high school education, or parents combined have both completed elementary school. So it kind of depends on the scenario we're interested in, what is kind of an interesting level. Here it's kind of maybe not that obvious because it's kind of two numbers added up. But in other cases it might be kind of obvious what you might want to evaluate it at. So this could be the mean of the variable, so it could evaluate that the mean parental education level in the sample, this says mean, might be hard to see, could be a 25th percentile, 75th percentile, the median, 50th percentile. So kind of any kind of different points along this distribution, you can kind of understand how the effect of education changes with these different levels of parental education.